Hi, welcome back to Unit 10, Day 8. We're still looking at similar surface area and volume. When I look at the fifth example here, it says the ratio of the diameter of a large circle to the diameter of a small circle is 5/4. And we can tell that because the 5 is bigger than the 4, so it has to be the large circle over the small circle. We're going to write the ratios to represent the ratio of the areas and the volumes of the larger circle to the smaller circle. So I'm going to create my SPOV table. It says the ratio of the diameter. The diameter would be considered a part, right? That's a part of the circle. Okay, it's not the area of the circle, it's not the volume of the circle, it's the part of the circle, right? So I'm going to say the ratio of the parts is 5:4. So that's going to go here. Okay, so then my scale factor must have also been 5:4. The ratio of my areas, we square the scale factor, so 5 squared is 25, and 4 squared is 16. And then for volume, we cube. So 5 cubed, 5 to the third power, or 5 times 5 times 5, is 125. And 4 to the third power, 4 times 4 times 4, is 64. The ratio of the areas is, the ratio of my areas is 25 over 16, which we can write as a fraction, we can write it with colons, we can write it with words, right? So there's 3 ways to write it: 25 to 16, 25 to 16, or 25 to 16. All 3 of those are the same answer. Okay, now this is kind of a trick question because my next one says, what is the ratio of the volumes? But we're looking at circles, right? Circles don't have a volume because circles are flat. So for the ratio, even though we can fill out the table, there's really not an applicable ratio of volumes because there's no such thing as volume to a circle. So this, we can put NA, not applicable. There's no such thing as the volume of a circle. So we don't have a ratio of volumes because they don't exist. Okay? All right, let's look at number 6. Hopefully no more trick questions. All right, so number 6, the length, width, and height of a cube are changed to 6 times their original size. By what scale factor does the surface area of the cube increase and then the volume? Okay, so I am going to still make a SPOV table. Okay, and it says my length, width, and height of a cube. So it is 3-dimensional. I will be able to do volume this time. Okay, are changed to 6 times their original size. By what factor does the surface area of the cube increase and then the volume increase? Okay, all right, so I know that all of my sides are increasing 6 times the original. So that means that is a 6-to-1 ratio on the length, the width, and the height, right? 6 times whatever it originally was. So 6 times 1, right? 6-to-1, which means my scale factor is also 6-to-1. The ratio of my areas is 30 squared. So that's 6 times 6, 36-to-1. And the ratio of my volumes, is going to be 6 cubed. So 6 to the third power, 216-to-1. So my surface area, it says, by what factor does the surface area of the cube increase? My surface area will be increased by a factor, of, look at my areas, 36-to-1. So it'll be 36 times bigger. So a factor of 36. My volumes will increase by a factor of 216 to 1. So it'll be 216 times bigger. So 216. Okay? So that's just looking at your SPOV table and then looking at what it means to have those numbers there. Okay? When we come back, we'll look at these last two problems that go with looking at the surface areas and the volumes of three-dimensional statues. All right, so come on back for this application problem in the last video.